Good afternoon, ladies and gentlemen. Welcome to the second installment of our SFML game. Before we get started, we are going to get a column guide extension from the Visual Studio extension menu. Now that we have that out of the way, we can actually get some work done. Our first order of business is to remove the Hello World snippet that we inserted in the last part of our video. If you haven't seen that part, go check it out now and learn how to set up our project. The first thing we're going to do is create the logger header file. We can add our specification to this, and the compilable CPP file will be created automatically for us later. Because it's our singleton class, we're going to make the constructor private. That way, no one can create more than one instance of it. Notice how I've added the IOStream header so that we can use the OStream class. Part of being a singleton is that I don't want this to be created by anybody other than the first instance. I also don't want it to be copied or moved. This is easily accomplished by deleting the constructors for copying and moving, and also deleting the constructors for assigning. That way, we've only got one instance and it can't be created, moved, or copied. It looks like we installed our column guide extension, but we forgot to add our column guides. So let's go ahead and do that. I chose yellow because it sticks out. Not many of the text is yellow. The next order of business is to create the subclass that other classes will inherit from. The reason for this is that we want those classes to have their own locally scoped logging functions that can be called separate from the actual logger. This code is currently in a state that I like to call a living document. That means that a lot of the things, the way they are now, is probably going to change by the time our code is done for this particular class. Here we are creating a new file to hold the implementation of the log function. The reason that we have to do that is that the log function needs to exist after the logger class has been fully defined. The reason for that is because this log function will make use of the getInstance function in the logger class. In order to use a function that's part of a class, the class must be fully defined, or we'll get an error that is called C2027 use of undefined class. I'm about to do something fancy here. I'm going to call the log function inside of the logger class, and I'm going to forward every argument to it. The use of forward allows us to move any R value references and pass by reference any L value references. This way, anything that can be moved will be moved, and anything that can only be copied will be copied. And things that can be passed by reference will be. After realizing that I'm only going to have this one class for the whole file, I decided to move it into the main header file and then remove the extra file. Had I had multiple classes or multiple functions for that class, I would have kept it in its own file, but I don't think that's necessary for this particular instance. Here we're creating the getInstance function. It's a static function which statically allocates one instance of logger and then returns that instance. Now, every time you call getInstance, you're returning the same instance of the logger. This is how we accomplish our model of singleton. The only way to get the instance is to call getInstance, and it returns the same instance every time. Thus, we have a class that can only have one instance in existence on account of our constructors and assignment operators all made private. I've decided to move the arguments out of the constructor so that it can be default constructed. The stream buff will have to be counted for somewhere else. Headphone warning. We're about to hit with some tunes. Headphone warning. It's loud at first, but subsidizes. There we go. This is some proper developing environment now. We always got to have some good tunes. Here we are continuing to redesign the constructor and removing its parameter. Notice how we use the default construction in the static variable that we return as well. Bye-bye parameter. Now we are default constructible. The stream parameter that allows our logger to be configurable is being moved to the loggable class. That way, each class that implements the loggable class can define its own stream. The loggable class will have a construction parameter because it does need to know what stream buffer to write out to when it logs. We're going to now create a second variadic function that will allow us to more effectively utilize our logging functions. Now we're going to create a series of log helper functions which are going to help us unpack our variadic arguments. There is an interesting way to unpack variadic parameter packs right into a stream, but it's complicated and it looks ugly, and I would rather have 10 lines of readable code than 1 line of garbage. This particular function that only takes the stream buff pointer is going to go away eventually. The reason that I had this in there to begin with was it was in there the last time I designed a parameter unpacking set of overloads. And I'm going to quickly realize in a minute here that for this particular instance, it's not required. Right about here is where I decided that I was going to use a different style. Normally I use the capitalization on the first letter and camel case together, but I'm not going to do that for this project. We're going to use the normal C++ standard library style, which is a word, an underscore, and then another word, and then an underscore, and however many words and underscores it takes to write the name of the function. And all types will be lowercase. This particular type of organization isn't popular among some developers, but I prefer it. It makes things so much easier to find when done properly. The original design called for this enum of different log types in order to distinguish between things like notes and warnings and errors and critical warnings, but I quickly changed my mind when I decided that it would be easier just to create overloads. It might not always be easier, but in this case there's only 4, so it actually would be quite easier than having to write all of the handling code to deal with these bit flags. The new design is that the user of the class will call log note, log warn, log error, or log critical depending on what kind of log they would like to do. This is a bit faster than using bit flags, and it takes a lot less writing of code to deal with those bit flags and do error checking on those bit flags. Of course, this might violate the don't repeat yourself paradigm of programming, but I disagree. You'll notice that I'm using a log function inside these functions, which makes these functions really just an adapter to the log function. Of course, I'm just trying to justify my decision. Whether it's bad or good is up to the viewer. Now it's time to test some of our code. We're going to do this by creating a test class that inherits the loggable class, and then we're going to do some logging. Hold on to your seats. This is going to be a wild ride. I'm going to go ahead and leave the errors shown so that you can see how they were resolved. I like to think that I resolved them pretty quick because I'm pretty good at what I do. Again, that's something we will leave up to the viewer. It might be a bit self-serving, but leave a comment if you think I could have done better. But don't bother leaving a comment unless it's something constructive, and that's something that we can all learn from. I know that we get socializing points for any kind of comment, but I'm not interested in that. I'm interested in having a constructive conversation with people. You may not be able to tell this, but I'm a little sensitive about my errors. So please, if you're going to get on my case about it, be constructive. I welcome constructive criticism. You may or may not be rude. Rude constructive criticism is still constructive criticism, and I welcome it. I'm an adult, and I can take it acting like an adult and not get all offended because my fifis were hurt. Don't worry. I'm not sure why the error list didn't pop up when I opened Visual Studio, probably because this is a new user account on this PC, but we're all going to learn how to load up the error list right now, if I can ever find it. The first error we're looking at is an error of the type cannot convert the this pointer to loggable reference. I'm sure we've all seen this before. It means that we're calling a non-const function from a const function. As a young man, this kind of error really irritated me because it was hard to figure out until you knew why. And now all of you know why. So in the future, I expect to not see this error last too long on your screen. The next error that we're going to tackle is an error where I tried to call a log function directly as a static member of the logger class. The resolution for this error is to call the static function getInstance, and then we can call log from that. That was a quick solve because I love singleton classes and I use them whenever the need arises. Now we have a compiling example. Now it's time to do some customization and get the logging output to just the way that we want it. I plan to add a thread ID. Here you can see that I've noticed that this function is never being called. That's because in this particular instance, it's not needed. So I've moved the end line to the function above it. And now the log will properly end the line after its logging is done. Observe. Here we're going to add the thread and mutex library so that we can create some thread-safe logging. Part of having a class that uses threads is making sure that threads are built into the core functionality of the class. That's why I've decided to add a thread ID to the logging output. The reason that we need to do it like this is because we may have multiple threads logging at the same time, and we don't want jarbled output. You can see here I'm making use of the internet to find out how to do this one thing. What I want to do is I want to convert a thread ID to a string without having to go through a string buffer. Excuse me, a string stream, because it's a bulky class and it's expensive, but I ended up using it because it's the only way. It is the only way. Here I'm trying to determine exactly the largest number that a thread ID can be. Of course, something detailed like this, I wasn't able to find a direct answer. The original plan was to convert the thread ID to a fundamental data type 64-bit int or 32 depending on its max size. Then that could be logged directly. Of course, this whole train of thought was an utter failure, and I ended up using a string stream with returning a string after all. I noticed here that the stream operator returns an O stream instead of the type of stream that you used it with. You'll notice the way that I solved this problem is by inline casting. I'm not sure if that's even a term, but I casted the result back to a string stream reference, and then I was able to use the temporary object as I intended. Notice how I will be altering the log functions so that they will display the thread ID that it came from. This is important because we may have multiple threads running different classes that will all want to log at the same time, and we don't want jarbled output. And now we get to see some more output. Here we're adding a mutex to assist us with the thread safety portion of our class. The mutex will be locked at the beginning of the log function, that innermost log function. That way, other functions that call it will continue to run until they hit this function, and then they will wait their turn in line. The lock guard is a special class that will lock a mutex and then unlock it when it loses scope. That way we don't forget to unlock the mutex, which will cause us to have a bad time. If you don't unlock your mutexes, you're gonna have a bad time. Here we have some more output, and you can see the thread ID. It's time to throw a couple more threads into the mix so we can actually test our multi-threaded support. As you can see in the following example, when we test run the application, none of our output is jarbled. Towards the end of the video, we will disable the lock guard and see a whole bunch of jarbled output. Look forward to that. It's a wild ride. Here we're going to start creating a series of macros that when run in debug setting will actually log stuff, but when run in a release configuration, no statements will be executed or even exist. Here we're going to create the function that gets called by the macro, and we're going to name it in a way that people won't call it individually, because if they call it directly without using the macro, then it will still log stuff in the release configuration. Now it's time for everyone's favorite part, the testing phase. We start this by creating a small, simplistic unit test for our logs. I'm not logging streams here. There's a lot of stuff in here that does not need tested because I can be reasonably assured that the streams are going to act as expected. We're just going to test out the weird functionality that is not part of the standard library, mainly the singletonness and also the debug logger, and make sure that it doesn't log during a release version. Here we're going to add a little feature that will allow us to redirect all streams to a stream of our choice. This feature is going to exist in the singleton log class. Because all other log functions are piped through this class's log function, we can control the destination of every log by setting a different stream in this log function. Here we're about to remove our lock and then test out the output. You can see how jarbled it is, so our thread safety is definitely a necessary requirement. That's all for this part. Join us for part 3, where we may do something more interesting or less interesting depending on your point of view. We may do it as a live stream, and if we do it as a live stream, any viewers are welcome to throw out some input. And I'm not 100% set on the design yet. I'm kind of going along as I go, just because it's more fun that way for a personal project. I may end up taking a lot of advice from viewers. In fact, if you have something you're not sure will work, we'll give it a try in front of everybody, and we will face the consequences of their constructive criticisms. Before anybody asks, I will not be posting the source code until it is all done. If you would like to follow along, that would probably be really fun, but it's up to you. Good night, everybody. See you on the next installment.